Today we are going to start electricity, second portion of Edexcel International GCSE exam for physics. And electricity means we are going to study about charges at rest, charges in motion in the form of dynamics like electric current with the having units of ampere or like that. First of all, I will go towards the circuits, the basics over there. Circuits, the basics over there. If we go for circuits, the basics towards the first topic of this section, we can simply say electricity is rate of flow of charges and directly related to current. First of all, I will have to move towards current to explain electricity in the circuits over there. I will say it is a rate of flow of charges is called electric current, and its unit in which it is measured is called ampere, denoted with symbol A. And we use a device named as ammeter to measure the current. Ammeter, which is connected in series so that maximum current can flow through that circuit over there. And ammeter, after that, we will simply say here, according to formula, as I said, rate of flow of charges over there. So current is equal to charge over time there. Charge over time, then it is symbolically, the symbol is I is for current, Q is for charge, and T is for time over there. If 1 coulomb charge passes in 1 second through a point, then the current will be 1 ampere. If 1 coulomb charge flows through a point in 1 second, then the current will be 1 ampere. Basically, we consider that when the charge is flowing, it means we are talking about the conductors in which free electrons are flowing under the action of some EMF or potential difference or voltage over there. For that, say, conduction is being done for the electrons over there. So electron is basically the charge with the value of 1.6 multiplied 10 raised to power minus 19 coulomb over there. And these electrons are flowing freely in the conductors of metals over there. And those conductors are having a negative charge. Electron is basically having negative charge over it. This negative charge should be taken, and current, when I am talking about, for example, let's suppose I am taking a circuit over here in which I am saying there is a battery source. There is a battery source which is connected with a load resistor over there. And if electrons are flowing, then definitely the big line shows the positive terminal of battery, and negative line shows, the small line shows the negative terminal. And if I say the current is flowing due to flow of electrons through it, then it is coming from negative terminal to positive terminal. And negative terminal of battery is called low potential of battery, negative terminal, to high potential, which is positive terminal of battery, and the current is flowing from low potential to high potential. That is called electronic current. And if I am talking about the high potential to low potential, then I will name it as from positive terminal to negative terminal, which mostly the current flows over there. But if I am talking in deep with the help of electrons or like that, that is called electronic current. But in general, current flows from positive terminal to negative terminal, and we can name it as conventional current over there. When current flows from positive terminal to negative terminal, from high potential to low potential, then we named it as conventional current. For flowing of both of these cases, we will require a voltage, we will require a EMF of source over there. Then I will say that is electromotive force, means the energy provided by a battery, provided by battery to accelerate the charge, to accelerate the charge through the circuit. The circuit is called electromotive force, is called EMF of the circuit. So EMF is equal to work done per unit charge over there, work done per unit charge. For that case, we take E is equal to W over Q. And for its unit, we can take joule per coulomb, or we can name it as volt as its basic unit over there. And if I am talking like how much voltage is present across its resistor as a voltage drop or the work done over there per unit charge, while charge is moving from this end to this end through this resistor R over there, then that is called potential difference. Potential difference. Then the formula is the same again. Then we will say work done per unit charge through a resistor, through a load resistor, through a electrical component, through work done per unit charge through an electrical component is better option. Electrical component is called potential difference. For example, I say this terminal is A, this terminal is B, and you are accelerating work done. Then work from A to B over charge will equal to your voltage. For EMF measuring or for voltage measuring of a battery or a component, we say we use a device called voltmeter that is connected in parallel. And this voltmeter measures the voltage or EMF in the volts over there. Always remember here one or two more three things over there. If you increase the voltage, then more current will flow. And if you increase the resistance, less current will flow. And if more voltages will be needed to keep the same current flowing over there, more voltages will be needed if resistance is going to increase for the same current over there. Then I will say here that I will introduce here a relationship between voltage, current, and resistance over there. In that case, I will say voltage is directly proportional to current. Like voltage you will increase, current will increase. On the other hand, if I want to remove this relationship sign over there, proportional sign over there, I am introducing V is equal to IR. And if you are taking to make I as a subject to show that how much the current is increasing or decreasing on changing voltage and resistance over there, then we can say I is equal to V over R. It means if you are increasing voltage, current will increase. If you are increasing resistance, then current will decrease in that case. That is inversely proportional over there. If I want to show here about the ammeter and voltmeter to be connected and how to get those values over there, then I told you that, for example, let's suppose I'm getting a cell or a battery over here. I'm getting a cell or battery over here. I'm getting a battery now, right now. This is positive terminal, this is negative terminal. And here I will use conventional way. I will not use the electronic way to show the current. That current is moving from positive terminal to negative terminal over there. I am introducing a variable resistor over here. Variable resistor over here in this form. This is a variable resistor. And I am introducing an ammeter in the pathway, which is to measure the current in the circuit. Then I am also connecting a electrical component in the form of a fixed resistor over there. That is a component that is a resistor, and along which I will provide a voltmeter over here to measure the voltage across this electrical component over there. And then I will connect this to this form. So current is going from positive terminal to negative terminal in the form of conventional current over there. Then I can say that as the ammeter is connected in series across this electrical component of resistor R over there, this is variable resistor, ammeter, voltmeter, and battery of the cell over there. So ammeter will measure in amperes to the current which is flowing through this electrical component of resistor R. It should be must be placed in series over there. If you are place it in parallel, it is not going to give you the exact values which are required over there. And never in parallel like voltmeter. It should never be taken. On the other hand, voltmeter measures the voltage across this component over there. This is voltmeter over there. It will measure the voltage across this resistor R over there. And it must be placed in parallel around the component under test and not around the variable resistor or a battery. Not to place it here across variable resistor or here across voltmeter battery over there. Try to place it across a fixed resistor over there so that voltage can be measured. And the very basic circuit will be used for testing components. And from this very basic circuit, I will say for getting IV graphs, current voltage graphs, current voltage graphs can be obtained by using the values over there. The component, the ammeter, and the variable resistor in series, all in series, which means they can be put in any order, okay, in the main circuit. And the voltmeter, to the on the other hand, can only be placed in parallel across the fixed resistor over there around a component under test over there. So anywhere also definite no and never should be placed for the voltmeter over there. As you vary the variable resistor, as we change its resistance of variable resistor over there, then we can say here that it alters the current flowing through the circuit. Like this resistor is in series, and here I am just changing the color. Wait a second there. As you change the resistance, then it will result change in current in the resistor. It will be in the whole circuit over there. So this allows you to take several pairs of readings from ammeter and voltmeter. Definitely, they will change their values across the current for ammeter over there. They will also change the value of voltmeter, and you can get many values of pairs of readings over there. And then you can easily plot the graph for current and voltage to get IV graphs over there. So here I will try to explain about this relationship which we have already written in above form, I will say there that if I take voltage is equal to current multiply resistance. This is also named as Ohm's law, which states that Ohm's law. It states that voltage across the, wait a second, I want to show you here. For example, if we are talking about this, voltage across the ends of a conductor or a component over here, like here and here, voltage across the ends of a conductor, ends of an electrical component will be a better option. Electrical component is directly proportional to current flowing through this circuit. Component is directly proportional to the current flowing through it at constant temperature and pressure. This is called Ohm's law. And if I take this relation, V is equal to, I'm also showing this formula in the form of a triangle, which you can use for different formats over there. Here it is voltage, here it is current and resistance. If you need voltage, then multiply them. If you need current, V over R. If you need resistance, V over I. So this relation can manipulate for calculation of different values. And if I want to take, you can use this formula to work out the further resistance as a pair of values of VI in IV graphs over there. And if we are going to plot the graph between I and V over there, like this, like you are saying that you are taking R is equal to V over I. R is equal to V over I. But if you are plotting a graph with V on x-axis and I on y-axis, this is the proper way, you get a straight line over there. Always remember here one thing, that if you take directly the gradient of this graph, you will get the resistance, which will show that it is having a constant value over there. Then this constant value should be taken in the form of gradient, but gradient will give you the 1 over R value if I is on y-axis and x is on with the v-axis. Voltage on x-axis and I on the y-axis, then gradient, you know the formula of gradient, M is equal to y2 minus y1 over x2 minus x1. Then it will give you the resistance for 1 by R, and then you will reciprocal it, and you will get R will equal to V over I, and then you can get these values over there. If you are showing it for, you can say you are taking for wire, then this will hold to show that the temperature is constant and it is not varying over there. But if you are going towards a filament lamp bulb, which is having a yellow light and having a tungsten spring-like wire into that, then we know that as the temperature of the metal filament increases, resistance also increases, and hence it shows the curve over there. Then if I want to show here for a filament lamp over there, filament lamp, then in that case, I will say here that the graph will stay straight, then it will show curve over there. And in the same way, it is showing the curve over there. So it means the graph is going to follow the Ohm's law till here, but after that, it has deviated. Such devices which are not following this voltage to current relationship of graph in the form of straight line to show the constant resistance are called non-ohmic devices over there. We also use this one, devices over there. And for different resistances, we can say the current through resistor at constant temperature is proportional to voltage. And different resistors have different resistances and slopes over there. Then these graphs can also be in the form of this, in the form of this. So that should be straight line for different resistors. It should have different values over there. If I go for diode or like that, diode is a device which show the current flow in only in one direction, like diode. This is its PN junction over there, and the diode allows the current in only one direction. For example, the input is in this form, the output will be in this form only. Space is there, only in one direction they will show their output over there. So in that case, I will say if I plot a graph between voltage and current over there, then it will show its threshold voltage. And after crossing the threshold voltage, it will go to the forward direction current. In the same way, it is showing the same pathway. So it is not following the straight line curve for voltage and current over there. So when he crosses his threshold voltage, which is taken 0.3 for germanium case and 0.7 volt for silicon case, we can say after just crossing this limit, they are showing the abrupt change in the current over there. So this is the way how to describe about IV graphs over there. After that, I will move towards a little bit symbols of different devices which we used on daily basis in our electrical components to show in the circuit over there. Then I will say here the cell is having the same symbol, positive and negative. This is called cell. If we go more to join 2 or 3 cells over there, like 1, like 2, like 3, then this will named as battery. And remember that positive is big line, negative is small line. Positive is big line, negative is small line over there. So after that, power supply for DC, we are taking empty bubble there and showing this and this form and just giving in the form of power supply with positive and negative. This is called DC power supply. But if I go with the same bubbles and I am showing here a small little bit of sinusoidal waveform from with the then it is called AC supply there. There is no positive and negative phenomenon overshown in this form. When switches are open, then there is terminal, and this one and this one. And I am showing that it is in this form. It is not connected like this. Or switch open can also be shown in the form of this format, like the wire is only available at its upper side over there. When it is taking close switch, then definitely I will join them like this, I will join them like this, then the switch will be closed in this form. After that, the earth of the wire can be shown, and earth is shown like this is the wire, and you want to earth it, then you are taking like earth as the having this symbol. This is for earthing, like extra charges deposited on a heavy machinery over there should be neutralized by using this earth wire over there. After that, there is a circuit breaker fuse over there. Like this is a rectangle to be taken in the form of fuse. Then we can say it is a safety equipment for the heavy machinery. In case of this is called fuse. If I am going towards transformer, then this is a spring-like curve within a single line, and this is also available. This is used for transformer over there. On the other hand, if we go for filament lamp, then it is a cross with the extended wires. This is called lamp. Okay. After that, light emitting diode can also be used, but no need to go for motor. If you want to show some motor, maybe in O levels, we will not be going to use this one, but O level or IGCSE, we are not going to use, but in A levels, it will be maybe needed over there. After that, heater. In this form, this is like a heater. These are some symbols which are used for daily life in the circuit. In the same style, if you are going for generator, you are just placing G over there. And for fixed resistor, we are using a rectangle there. This is called fixed resistor. Over there, if we are going to variable resistor, then as I have used in the above circuit example, we are going to draw a arrowhead like this to show the symbol as a variable resistor over there. Ammeter, voltmeter, we already know that this is ammeter, this is voltmeter, and then there should be LDR or thermistor. I'm going towards thermistor because mostly circuit we mostly observe that, and sometimes he asked us about the names of that component also, or to draw the symbol. Thermistor is like this, and a small line like this. This arrowhead should not be there. Wait a second. He has given me in wrong way there. Arrowhead should not be there. Like this form and like this form. Okay, this is called thermistor over there. These were little bit symbols and should be taken. If I go towards the explanations of these little bit symbols, I think so mostly you are familiar with. But if we go in detail, then here I will try to describe about light emitting diode. Light emitting diode like LED, light emitting diode. This is called LED, light emitting diode. If I talk about this, it can emit light when current flows through them in the forward direction, and they have a lots of practical applications. If I draw its symbol over there, then I'm saying here I'm drawing the diode symbol exactly same, but I am going to give its circle around it and showing its symbol like it is emitting when the current is entering into it and current is leaving to it. So they are used in the number of digital clocks, in traffic lights, and in remote controls over there. Unlike a light bulb, they don't have any filament and that can burn out and they can, we can say, not reusable over there. So LED like lamps indicate the presence of current in the circuit, and they are often used in appliances to show they are switched on, like in your TV or in your remote or like that, they are present over there. So some other components which I will talk about this, that is LDR, which we are using in our street lights over there. Light dependent resistor is also being taken as light dependent resistors. Light dependent resistor, if I talk about it, it is like in the form of resistor to be taken in the form of a box like that, but light should fall on it. And when the current will enter into it, it will show some phenomenons over there. And it will be used as a street light controller over there. Light dependent resistor is a special type of resistor that changes the resistance depending on how much light falls on it. How much light falls on it. At daytime, if I talk that too much light is falling on it, then the resistance will be much higher. It will not allow to flow the current over there and circuit will stay switched off. At the night, where it will light intensity will decrease, resistance will decrease, and they will allow the current to flow through it. In the bright light, the resistance falls, and in the darkness, the resistance is highest. And this makes a useful device for various electronic circuits like burglar alarms over there or burglar detectors over there. And we also talk about this thermistor. If I am talking about, then I will simply say here a thermistor is a temperature dependent resistor. In hot condition, resistance drops, and in cool condition, resistance goes up. For example, if I say a simple example, like if I say LED bulb, LED bulb, for example, I am taking that. What will happen? When you turn it on, its light is dim. But with the passage of time, as it gets heat up a little bit, its brightness is going to increase, which show that LED bulb is basically uh, getting its resistance to be increased over there. So as the temperature increases, the resistance decreases. But in normal resistors, it does not happen. In normal resistor, for example, temperature and resistance are directly proportional to each other. This happens in normal resistors. On the other end, in thermistors, as temperature increases, resistance decreases. This is the behavior which will be shown over there. Why in normal? Because they are made up of solid metals over there or conductors over there. Their atoms start to vibrate with the larger amplitude over there, and it is providing an extra resistance in the path flow of current over there that is more dangerous for that case over there. So here I will say here that the thermistor make useful temperature detectors, car engine, like if you mostly observe in the dashboard, then we can say dashboard of car. This shows that what is the temperature of car engine. It is heating up or it is working normally. Then the sign is being shown with the help of thermistor. Thermostat or fire alarms can be used in case of thermistors to be shown over there. So tomorrow we will go with the series and parallel, a combination of the resistors. For today, this is your electrical circuits basics about their devices, their components, and their all workings over there. It is related to the main topic of your paper. So try to focus and revise all of this and watch this video again and again if you want. If you are still confusing with your current topic over there, and kindly subscribe my channel and like the video and share the video. Thank you so much for today. Allah Hafiz.